Hi, this is Tori with Live Your Life Well, and today we're going to be doing some testing on some area wells. To my right, I have a Bowman Kemp 563672, the most popular size. To my left, I have a 553672 by Monarch, their most popular size. What we're going to do today is we're going to put bags of pea gravel at the midpoint of the area well, and we're going to stack them to find soil pressure simulation for compression and collapse. We're going to measure the deviation as we add weight to it to determine how much this deflects in and at what point we are no longer code compliant for 36 inches projection. As you can see here, 36-inch projection is what is required by code, and we are dangerously close to not meeting that measurement initially with the Bowman Kemp product. It is right on the bubble of being compliant. And this is a Monarch, also 36-inch projection, and again, right on the limit of whether or not this is compliant with code. 36 inches is the required amount, so if we deviate at all on the deflection, we're technically no longer compliant with the law. As you can see, we've mounted both area wells to this concrete slab using 1/4 inch by 4 inch Simpson stainless Titan concrete screws. They're made specifically for this application. The reason they're not buried all the way is because there is no need. As we put pressure downward on the area well, it's going to push this harder into the concrete. What we're looking for is lateral pressure spread. This won't allow the area well for its legs to come out. These are 4 inches long, so they're buried roughly 2 inches in the concrete, so they're quite strong. As we add weight to the top, it's going to want to force the legs out initially. This will capture that movement and isolate it and put all the pressure to a collapse. So for our weight loading purposes today, we're going to use Sackcrete all-purpose gravel in 0.5 cubic foot bags. They weigh 50 pounds per bag. So we're going to get started with the Bowman Kemp well. As you can see, the starting measurement is 36 inches of projection. We're going to check and see how much it deviates as we add weight at 50 pounds per bag. We're going to time lapse it to save you some time. As you can see, there's 10 bags, which is 500 pounds. The Bowman Kemp area well is holding up quite well. So now we're using a straight edge to show you how much it's bowing. Right there, we've lost a 1/2 inch. We are no longer code compliant. We have 20 bags, which is 1,000 pounds. So you can see we've added another 500 pounds. We're at 1,500 pounds, holding strong at 35.5 inches. You can see she's bowing a little bit. We're now down to about 35.25. We have 2,000 pounds on it, so very strong. 2,000 pounds stacked, and it's only deflected 3/4 of an inch. As you can see, we're starting to approach the danger zone. We have 2,600 pounds of vertical pressure, which would simulate horizontal pressure during the backfill. The Bowman Kemp wells held up very well for being a 16.5 gauge steel. It's very strong. What we can't measure here is the ability for this deflection. And as you can see, I can use one finger and I can make this well deviate from its shape. That is potentially dangerous during backfilling. If you put pressure on this side, it pushes it out of the correct dimension coming from the wall. It goes both ways, and you'll find that common where the grate will no longer fit on top of the well because it is skewed during backfill one side or the other, depending upon which side you filled first. Okay, now we're going to check the Monarch well. Prior to any loading, we're at roughly 35.5 inches, so technically this product is not code compliant before we've put any weight onto this product. It is required to be 36 inches projection from the foundation wall, with the floor being the wall stood vertically. This area well is not code compliant, brand new, untouched, no weight on it. Not good. So you can see we've got 10 bags on, which is 500 pounds. This Monarch Stiffback 2 doesn't care. So you can see that's with 10 bags on it. Sorry, as you can see, that's with 20 bags on it. We're at 1,000 pounds and we're still at a ½ inch under code. It's remained constant, but still non-compliant. So you can see there's a little bit of bow, but very little. 2,000 pounds on it, and the Monarch Stiffback 2 is holding up very well. We're still at a ½ inch of deviation, but it's about where it started. So you can see we have some slight deviation in the middle where she's bowing downward. We are now at 35 1/4 as well. So both area wells holding up very well. I do think, however, the Monarch potentially is a little stronger in the side-to-side movement. Still not very confidence-inspiring, however. So now we're going to check out the LifeWell. We've got a couple variances you need to see. First and foremost, we have a built-in ladder that also acts as a strengthener in this profile. You can also see our dimensions are exceeding code by quite a bit. 36-inch projection is here. We are 2 3/4 inches further to allow overhang from siding or stucco while still remaining compliant with the 36-inch projection code. You're allowed a 6-inch further ingress with the steps. However, you can see because we are so much further out, even with the step, we're at 32.5 inches to the inside of the step, giving everyone just a little bit more room, again, for safety. More room allows more sunlight down into the window. It also allows a larger escape hatch if necessary. Also, you can see one of the benefits of rotomolding is we get incredible consistency. Notice there's no rocking motion in this board. They are exactly the same projection each piece. There is no ability to walk as we were getting with the other pressed steel or corrugated steel. Not a thing here. And as you can see, we're using the same stainless fasteners by Simpson. They're 1/4 by 4-inch Titan HDs. They are not buried all the way. Again, not necessary in this application. We're looking for shear load. We did the exact same count, 6 bolts per side. They are not buried, so we're not trying to cheat. The only way to make a test good is to make it equal for all. We're going to show you why our product is superior. We had to change things up a little bit. On the LifeWell, due to the polyethylene being a little slippery with the bags, which is a benefit where your soil can't get a grip on your well and help pull it off your house, we're putting a piece of cardboard on here simply as a traction element. There's no advantage to it. It just keeps the plastic bags from sliding off our shape. So we've got not much on here, only 600 pounds. Wanted to show you a couple things. One, there's literally no deviation between the steps. 2, there's been no compression whatsoever. We're the exact same original measurement. Stay tuned, we're going to add more weight. We now have 1,200 pounds on it. Not much has changed. We do have a very slight deviation, about a 1/16 of an inch. Also, I want to make note, during the backfill process, remember how wiggly the competitor's product is? Look at the stability of this. It just doesn't move. As you can see, as we pan out, we have 2,600 pounds on this, which is what we loaded the Bowman Kemp and the Monarch Stiffback 2 with. We have very little deviation. There's about an 1/8 inch of tolerance play between the parts that are loaded and the parts that have very little weight on them. This first one has less weight, so it's not being compressed and loaded the same. Also, take note that during backfill, the problem happens when you put dirt on this side, it pushes the well to that side, which makes your grates not fit. Notice how strong they don't move at all compared to the corrugated steel versions. We're in Larkspur, it's 47 degrees right now. We're gonna leave this 2,600 pounds sitting on the LifeWell overnight, see what it does. I know some of you are probably concerned about plastic and its ability to maintain its strength. Through our design with the included step acting as a gusset for support, they're not going anywhere, but we're gonna leave them overnight and we're just gonna see what it looks like tomorrow. The low temp tonight is supposed to get down to 25 degrees. Okay, so we've seen how they perform in the cold, which is amazing. This material is 31 degrees right now. So what we're gonna do is we're gonna apply heat to it. We're gonna tent over this entire pile. We're gonna put a heater on it and we're gonna bring these up to 110 degrees. The goal here is to show you the operational window from minus 12 degrees in a previous video to positive 110 degrees to show you the performance of this product in a very wide range of temperatures. So as you can see, we've got it tented with some concrete blankets. We've got a ready heater going, Salamander, 50,000 BTU, and it's running, and we're just gonna let it run until the temps come up to about 110 degrees on the product itself. It's gonna take a little bit, but we just wanna bring it up to temp to simulate a nice warm summer day. As you can see, we've got this outer wall heated to approximately 105 degrees. And you can see on the inside, we've got it heated to as high as 120 degrees. They're gonna cool down rapidly because the ambient air in here is 28 degrees at the moment. As you can see, there's virtually no deflection. If we set this up, we can see we've got about an 1/8 inch of deflection total. That's going from 28 degrees to 110 degrees-ish. That's a pretty big operating window. And as you can see again, the double-walled feature, which is patented, the outer wall is deflecting slightly with the weight on it. The inner wall is unaffected completely. Still dimensionally accurate. This outside acts like a bumper. It can flex up to 2.5 inches until it touches that inside wall, protecting itself from itself. As you can see, we've now removed all the bags off it after they've been sitting on it 96 hours. Then we heated it to 110 degrees, some areas 120. We then took all the bags off it. And you can see here, this outer wall has a slight depression from that much concentrated weight. However, if you look at the inside, it's virtually unaffected. As you can see, still fully operational, good to go. Pretty darn tough.